Hello students, welcome back to Organic Chemverse. Today we are tackling another advanced problem to help you master the deep concepts behind organic chemistry. By learning how to think through these tough questions, you will be completely ready for the most challenging problems in your exam. Let's solve today's question using all the concepts what we have learned so far. And if you find this video helpful, please like, share and subscribe to my channel. So let's get started. For the given question, you have to find out what is the correct structure of the reactant from the given four options. You already know the structure of the product and also you know the reagents used in the sequence of reactions. Then how to find out what is the correct structure of the reactant? So this can be done using a technique called as retrosynthesis. In retrosynthesis, you will already know the structure of the product, but you will try to find out what is the reactant by using simple techniques like identifying the functional groups in the reactant molecule and what are the functions of the reagents given here. Let's gather all the information from the reagents given here. For example, what is LDA and what is its function? So LDA stands for lithium diisopropylamide. Then what is its structure? So you can see that there is lithium. So we will write that, right? And then there is a diisopropyl. So diisopropyl refers to there are two isopropyl groups attached to the nitrogen. And this nitrogen is carrying negative charge due to the presence of this lithium ion. So this is nothing but lithium diisopropylamide. What is the function of this LDA? LDA is a very good base. It is used as base in many reactions because when we use smaller bases like hydroxide, methoxide, ethoxide, these molecules can act as base as well as nucleophiles. Then there is a probability that we will get multiple products. Rather than using them as base, let's use a bulkier base whose function is only to abstract the proton. So it is going to take away the proton not just from the acids, it can also take proton from the alpha carbons of aldehydes, ketones, and even esters. Why am I specifying on esters? Because look at the molecule BCD. They are nothing but cyclic esters. In case of molecule A, you can see there is an aldehyde and ketone. So this LDA is used to remove proton from any of these molecules. Now, what is the function of the methyl iodide? Methyl iodide is used for methylation. So if you want to introduce a methyl group, so for example, if you want to form a carbon-carbon bond wherein you are introducing this methyl, right? So in that case, we use methyl iodide. Now, let's take the second reagent, lithium aluminum hydride. LiAlH₄ is nothing but lithium aluminum hydride, which is also written as LAH. What is the function of it? It is a strong reducing reagent. This reducing reagent can reduce aldehydes, ketones, and also esters. So we do have those functional groups in the given molecules. Now let's take the third condition, TsOH. What is TsOH refers to? It is para-toluene. So toluene is methyl benzene and then sulfonic acid like this. So here you can see that this is called as tosyl group. That's why we write it as Ts. And if there is OH, we write like this. So it's nothing but para-toluene sulfonic acid, nothing but PTSA. What is its function? It is just acting as an organic acid. And then we have propanone. So propanone is reacting with the product formed in the reaction, right? And it is forming a ketal at the end. So this is the last reaction happening, right? So we have some acidic medium and a ketone heating condition, which is forming a ketal. So this ketal is nothing but a geminal alkoxy product. At the last step, there is a propanone means what? The product formed here is ketal, which is obtained from the corresponding diol molecule, because whenever we have a ketone and it is reacting with the diol means what? It is going to form a ketal product. So here when we treat the reactant with the lithium aluminum hydride followed by hydrolysis, we have to get a diol. And what is the diol? You see, this is corresponds to the ketone part, right? So you can cleave the molecule over here and you can expect a diol like this. So here, this is where you are going to get an alcohol, and here, this is where you are going to get alcohol. So this is the last but one product, right? So how do we get this diol? Which molecule will give this diol? Check for the number of carbons. So there is a cyclohexane. Apart from the cyclohexane, we need to have 3 carbons, 1, 2, 3. Now look at this one. There is a cyclohexane and there is 1 carbon here. Even if we do methylation, we will have only 2 carbons. So this cannot be our reactant. What about here? We have 1 carbon here, 1 carbon here. When we do methylation, 3 carbons. So this could be our reactant. Same here also. This could be the reactant. But here 1, 2, 3 and methyl iodide, 4 carbons will be there. Not possible. So our reactant has to be either B or C. And you have already eliminated A and D. Now the job is very simple. Better you do these reactions for molecule B and C and check which among these two is going to give us the desired product. Since we have already eliminated option A and D as they're not matching with the number of required carbons, let's start the reactions with molecule B. When this cyclic ester treated with LDA, that is lithium diisopropylamide, where it will abstract the proton. It's going to abstract from here because this is the alpha carbon. Generally, the alpha hydrogens of esters are not acidic, but since we are using a strong base here, this hydrogen can be still be abstracted and we are going to get this carbanion. This carbanion can be stabilized by the ester carboxyl group. That's why it can be formed in the reaction. Then what happens? It's going to react with the methyl iodide. When the carbanion attacks here, it will undergo nucleophilic substitution reaction, and then we are going to get a methylated product like this. Before we start writing the next reaction, just verify where the position of methyl is. The methyl is not on this carbon, it is on the adjacent carbon. So this cannot be the reactant molecule. So B is also not correct. So the final answer is supposed to be option C. But let's write down the reactions and then prove that this is the molecule which is going to form the product as shown here. So what is the first step here? When we add LDA, here this is where the nucleophile will get generated and then it's going to attack the methyl iodide. That is the second step, but we are doing them in one step only, right? This is always done in one step in situ. That means whenever we are doing methylation, first we will take our reactant molecule and then we will stir it with LDA for some time and then we will add this methyl iodide drop by drop so that it will undergo methylation. Where the methylation is happening here. And check here, this is the carbon attached here which is attached to the methyl. So this could be our reactant, right? So now what we are doing, lithium aluminum hydride. This is a strong reducing reagent. It will reduce the ester. How it will reduce the ester? First the hydride will attack here. This bond will open and then it will form an aldehyde, right? So what will be the structure of the aldehyde? This is the correct structure of the aldehyde. But since it is a strong reducing reagent, it will reduce the given aldehyde to the alcohol like this. So, and also you see, we are adding water at the end of the reaction, right? So here you are getting OH and here this, it will become CH2OH like this. And then what happens? We are adding some acid with propanone. So we have to get a ketal molecule. So you see this OH, both of them will attack here like this, and they are going to form a cyclic ketal product. So how to write the structure? Look at this. CH2 will be here, which is attached to the oxygen. Here also same oxygen, but they are attached to the ketone carbon like this. And how many membered ring we got? Start from here. 1, 2, 3, 4, 5, 6, 7. Similarly, here also we are getting a 7-membered ring. And this is a correct product what we have here in the final reaction. Hence, the reactant is as shown in option C. I hope I made this question and the concepts clear to you. And if you still have any question, please do ask them in the comment section. And don't forget to solve a question included in this video. Please do like, share and subscribe my channel. Thank you.